Okay, so this is 1.2, limits of the function using properties of limits for calculus 1. My calculus 2 is already through a couple of these sections already. Finding the limit of sum, difference, product, all these things. Now, I assigned some homework to go along with this, so I'm going to try and get to those problems already. So now, first, from 1.1, what do we know about a limit? What has to happen for a limit to exist? Left and right go to the same number, right? So from the left side and the right side, it has to go to the same number, right? Does it have to exist at that number? No, it doesn't have to exist at that number, right? Okay, so we're going to try and figure out a couple of things. Limit of a constant. So constant real number C, which would be like a constant is a non-variable, like 5. That is a constant. Doesn't have a variable. So as x approaches C, and if f of x is just 5 here, if this is just 5, then my answer would just be 5, right? There's nowhere to actually plug in my x value to actually see. It's just going to be that number. So that's for a constant. Now, limit of right here, f of x equals x, then any number C, the limit, okay, the limit as x approaches C of f of x, limit of x, so all we need to do is just plug in for that number right there. So we're just plugging in the C value for my variable x. That's what it means. That's what that is saying. Alright, so for this right here of a sum. So if, I'm going down to this part right here. So if this right here, if both limits exist, then I could actually have both f of x and g of x. They both exist. So that means that I could actually plug it in for a limit or whatever. So both left and right are both going to the same number. Yes? Okay. Then I could separate this with a plus sign here. So I could actually take this whole thing here, okay, which is this down here, and I could actually separate it into two separate limits and then add those limits up individually. Okay, this makes a lot more sense working it backwards. When I have different limits here, then I could just combine it together like this. So do these and then plug the limit and I get the whole thing, the limit of that whole thing. Okay, it'll make more sense in a minute when we actually have some of the problems. All right, the limit of the sum of the two functions equals the sum of their limits. Okay, of a difference, it's the same thing, but this time it has a subtraction. So the limit, okay, I have two functions here and there's subtraction in between them. So the limit is, I could just subtract one limit from the other, like that. So I just find the limit of x, find the limit of g, and then subtract the two numbers. It's kind of easier. When you see this, you're like, oh my goodness, what is that hot mess? It looks confusing, because this is notation and stuff that you probably have never seen before. So that's why you're staring at me awkwardly right now. I see that. Okay. A limit of the difference of the two function equals the difference of their limits. Product. Limit of product. So now, same thing goes right here. So this right here, I am multiplying. So when I have limit as x approaches c of f of x times g of x, I could break it up. So I could just find the limit of this times the limit of this, instead of doing it all together. Okay, so first problem right here. Let's see if you guys could actually figure this one out. So if you were listening to what I said at first, what would I do with this one right here? Just what? Don't be afraid, speak up.
Plug 3 in x.
Very good, plug 3 in for x, right? This is, like I was saying, as limit as x approaches c, in this case my c value is 3, right? Okay, and then plug it in. So what's the limit of this one going to be?
3. No.
It's not 3. What am I doing? I'm plugging the 3 in for the x, right? So it's going to be 9. So it's basically going to be my 3 squared, right? So I'm just plugging in my c value, which is the 3 in this case, and then working it out. So the limit of this function right here as x approaches 3, it's going to give me 9. So if I were to graph this and look at it, both sides right next to 3, both sides left side and right side are both going to the number 9. In this case, 9 does exist for this function.
So this is, that's the V point where the two
Yeah.
are intersecting. So that
Yeah.
counts for like an f of x and a g of x. Like that's what
No, this one goes back to my very first one. Like, where's that constant one? Okay, right here. So just plug it in. So if it's just x, in our case, it
So
was
it's
x
just
squared, right?
by itself.
Yeah, it was just x squared for the problem that we did. So it's like this one here. Okay? All right, so now write this. The limit as x approaches -5. So let's, just goes like that. So it's basically -4 times -5, right? That's what it's saying to do. So my c value is -5, so I'm plugging in -5 in for the x's. Everywhere I have an x, I'm going to plug in -5. So the limit of this function right here is what? Come on, class. 20. Come on now. You guys got this. So I'm recording this so you guys actually have to sound like it's a big classroom. Okay.
Oh, so it's actually
Yes, I'm recording.
our
Yeah. No? You just all of a sudden got stage fright? Okay. So, all right, so how about this one right here? Finding a limit, okay, this one right here says finding a limit as x approaches 1. As x approaches 1 on this one. Okay, on your notes you guys are doing these, right? Okay, so let's see. I'm going to have okay, so I plug it in, right? So this is going to give me, let me see, that's 5. On the inside, this is 5, right? Okay, that's 5, and that's 2. And there's a multiplication there. 10, right? Okay, so this is 10. Yeah, very. Okay, it's... Okay, what about this one right here?
0.
Okay, left side, right side, but this is only right side, right? Is this going to be undefined or some type of hole at 2? Say no. Is there any restrictions on the domain on this one? Is there any place in which the denominator is going to be equal to 0? Say no. Is there any place in which that it's going to give me imaginary numbers? Say no. Very good. Okay, so there is no restrictions on this, so I could just plug this in as is. So even from the left hand or right hand, this right here from the right hand side at 2, so I can plug that in right there, and it's going to give me what? 0. Because on the inside I got 0 right here, and that's going to be what? 8, right? So 8 times 0? 0.
That doesn't mean anything.
What doesn't mean anything?
The n equal 0. It just means it's gonna meet at 0.
0 is a number, yeah. So if I graph this right here, I'll look at the graph and both sides of it together should be going to 0. Okay? All right, now find the function piecewise functions. So now, if this exists, so do you guys have your calculators? Okay, for those people who walked in late, don't do it yet though. Okay, we're gonna do it by hand. Grab your calculator. Okay, but we're not gonna do it on the calculator yet. I'm gonna show you by hand. Okay, so 2 is the point in which both these are come together, right? That's what I'm looking at here. I'm going to look at that part right there. So if I'm finding the limit at 2, I'm looking here first. Because if this said 1, which one would I plug it into? I would plug it in for x, but which one? Top or bottom?
Top.
The top, right? I would plug it in for the top one because that's all x is less than 2. Okay? Sometimes they'll trick you on this that you really don't have to do much more than, read what it says, understand it's only these ones right here, but this one they're both connecting here at 2, right? Okay, so now we're going to look at it at 2. So I'm going to plug in right here. So the function, let's see where, if it exists, there is going to be a limit at 2. So what has to happen on both sides of this one right here? So now I'm going to look at a number line at 2 right here, and I'm going to be going this way, and I'm going to be going this way from 2. So if I'm coming from the left-hand side, that's the top one right here, right? Okay, and if I'm going from the right-hand side, it's this one right here, right? Okay, so for the limit to exist, what has to happen? They have to meet at the same point. So the left hand and the right hand both have to go to the same number. So that's going to save me a whole lot of time, effort, and other stuff. All right, so let's go ahead and see if that works. So plug in 2. So this one right here on the left-hand side is going to give me 7. All right, now let's look at the right-hand side. Right-hand side, that's going to give me, that's going to be 1 and 4. So what do we get? Just 4. Okay. Does the limit exist? No, because the left hand and right hand aren't going to the same number, are they? So I'd say what? Limit does not exist. Okay, you can abbreviate with D and E. Okay, but you have to state that it has to be the limit does not exist. Okay, we're going to get other stuff later on. Okay, so AP testing type stuff, you have to say the limit does not exist. All right. Okay, so I think that is it for what we're doing today. I could still do this one here. I think it's this one. Hold on. Yeah, I could do these ones here. All right, so now again, limit as x approaches c of a product rule. So for this one right here, it's basically if I'm taking the exponent of the limit, I could just put this in and it'd be the same as finding the whole thing to that power. So if you notice where the brackets are now. So this is right here, just around the function. So I could change it to be around the entire limit and then raise that to the power. Make sense? So instead of just doing the function, I could just do the whole limit to that power. Same thing with a root. A root is basically an exponent. So a square root, so it's a square root of 5 is the same as saying 5 to the what power? 1/2 power. Okay, that's another thing. Okay, it's the same thing. It's the same rules as exponents because a root is just another type of exponent, just with a fraction. All right, so finding the limit of a power. How about this one? This one should be easy. What is it? 32. So this is basically saying that I'm going to have 2 to the 5th 32. Okay, what am I doing for this one? So it is, so 2 parentheses 1 minus 3 to the 3rd, which comes out to be -1 to the 3rd power, which is -1. Limit as x to the n, where n is a positive integer. Positive, that's important. Okay, can we just write out what this would be? It'd be what? C to the n. Right? So no matter what my positive integer is here, it's going to look like that, right? To whatever number I take that to. All right, so we're going to pick up the rest of this tomorrow. I'm going to give you guys some time for the homework and stuff, right, Meow? Don't forget, like, subscribe, right?